Welcome to this, the first in a series of videos where I'll be taking a look at Blazor WebAssembly from a beginner's point of view. First of all, what is Blazor? To get a definitive idea, I entered "what is Blazor" into Google, and this is the answer I got from Microsoft. Blazor is a framework for building interactive client-side web user interfaces with .NET. What this boils down to is that Blazor is just a way of building web applications. Further on, it says, create rich interactive UI using C# instead of JavaScript. Render the UI as HTML and CSS for wide browser support, including mobile browsers. It means that we're going to be using C#, HTML, and CSS. So in summary, I think we can say that Blazor is a method of building web applications using C#, HTML, and CSS. There are two basic hosting models for Blazor, Blazor Server and Blazor WebAssembly. There is a third, .NET MAUI Blazor, but for these purposes we'll be ignoring that and concentrating solely on Blazor WebAssembly. However, before we look at Blazor WebAssembly in detail, what are the differences between Blazor Server and Blazor WebAssembly? Blazor Server is really what it says. The programs or application for a Blazor Server application are stored and saved and run on the server, where the browser links to the server, but the actual program runs on the server. The application is normally connected to a database, which is again either on the same server or an attached server. So what are the pros and cons of Blazor Server? First of all, because the program is saved or runs on the server, the download size to the browser or client is small and is therefore relatively fast. The second thing is that all the processing is carried out on the server, so we don't need high-powered browser clients to run the application. The third thing is that the application is directly linked to the database, so there's no long routing between the application and the server. However, there are some cons. First of all, it is expensive to scale a large application. Now, when we say large application or a lot of users, what we're really talking about are literally thousands and thousands of clients. In this case, you'd have to have a server beefed up to run all the applications simultaneously. This is obviously going to be expensive. The most serious one in some ways is that if the client-server connection fails, the application will stop. So how about Blazor WebAssembly? On Blazor WebAssembly, the program or app is downloaded to the individual clients, leaving basically the link between the program or app and the database on the server. This too has its pros and cons. The first pro is that all the processing takes place on the client, so we don't need to have very powerful servers to scale up a very large application. It is therefore less expensive to scale. And thirdly, it will continue to work if the connection to the server fails. The cons are that there is a much larger download size, so the initial startup time for downloading an application to the client is quite long, or could be. This is relative terms, of course. We're talking seconds rather than anything longer. The biggest con is it requires an API to connect to the database. From a programming perspective, from what I've seen so far, this is the biggest downside. It requires quite a lot of work to link the client or browser application back to the database. But we'll look at this in detail shortly. What we're going to be doing in this series of videos is creating an application with countries and cities. And the reason I've chosen this is it's simply an example of a one-to-many relationship between two entities. Other examples might be customers and invoices, suppliers and orders, lists and tasks, products and components. The application is going to be simple, but it's not going to be trivial. We're going to be exploring some of the more complicated things that we need to link two entities together. We'll be using Visual Studio 2022, .NET 7, and to store the data, we're going to be using a SQLite database. We'll be using Dapper to link the application to the SQLite database. And lastly, we'll be using Syncfusion controls to provide things like grids, drop-down lists, modal dialog boxes, and other controls. But before we get going, let's have a quick look at how the finished application will look. When we start the application, this is what we see. We've got two menu items, countries and cities, and countries list. Let's start by looking at the countries list. And here you'll see we've got a list of countries, and we've got the options to add, edit, or delete a country. So let's try adding one. If we add one, a modal box pops up, and we can enter a country and save it. We've also got various safeguards in there. So if we wanted to add Japan again, it would say, sorry, we can't do this, it already exists. So we've got a way of entering countries, and we've got a way of editing. So if I select one, I can edit it and change its spelling. And similarly, if we wanted to delete a country, we select it and click delete. It'll ask us if we want to make sure, and we say yes. So that's the countries list. That's the main entity. If we look at countries and cities, we've got a drop-down list. This is one of the Syncfusion controls. And from here, I can select a country, or I can just start typing its initial letter, and it will appear. And now I've got the option to add, edit, or delete cities. So if I click add, again, we've got a pop-up box or modal dialog. And I can enter a city together with its population and save it. And I can carry on adding cities if I need to. So if I add another one, we can save it, and the population is shown here in this grid, and at the bottom we've got the total population of the cities that we've so far entered. That's it really. It's just a very simple application where we can add, edit and delete entities, and we can check to make sure that we aren't entering ones that already exist, and if we wanted to delete something, it just checks that we want to make sure that we do want to delete it. So that's it. So let's make a start on creating the application. Later on, we will be installing a SQLite database tool and a number of NuGet packages. But initially, the only prerequisite is that Visual Studio 2022 is installed on your PC. I'll put a link in the description to a website where you can download the Visual Studio 2022 community version. At the time of recording, I'm using version 17.4.4, but this is likely to change in the future. So don't worry if the version you download is a later version. To create the project, open Visual Studio 2022 and select Create a New Project. This will show a list of recent templates on the left-hand side, but to make sure you get the correct template, enter Blazor at the top here. And having done that, you'll get a number of Blazor templates. The one we want is the Blazor WebAssembly app. Don't select the Blazor WebAssembly app empty. We will actually need this one. This gives us it gives us some things that we don't want, but it also gives us things that we do want. So select that and click Next. Give your project a name. I'm going to call mine Blazor Countries WASM for WebAssembly. Select your location, that's my default location, and leave the solution name the same. Select Next, and here select .NET 7, which is the latest version of .NET. Make sure that configure for HTTPS is selected and ASP.NET Core hosted is also selected, but don't select any authentication type. In actual fact, if this was a real application, you probably would select that, but that's just going to add confusion for us at the moment. Select Create. And after a few seconds, the application is created and is shown here. This might be slightly different on your screen depending on your settings. Mine is set to the dark theme, which is to be found under Tools, Options, Environment and General. And I've also got the Solution Explorer docked to the right of the screen. Notice here that we've got 3 projects. This is the solution. We've got a client project, a server project, and the shared project. The server project is in bold, and that's because that's set as the startup project. So just run it to make sure everything works, and we should get this application running. Just check the counter, so that works, and fetch data works. So we can close that for the time being. The first thing we need to do is to add model classes. In our case, we'll need 2 model classes, one for the countries and one for cities. When we add the database later, the model classes will mirror the tables within the database. And for our simple application, the models and their fields are shown here. So you'll see that for the country, we'll need an ID and a name. And for the city, we'll need a city ID, the name. I'm putting in the population, and I'm also putting in their country ID. That's known as a foreign key, and that will be the link between the country table and the city table. To add these classes, select the shared folder, right-click and select Add Class. And we'll enter country as the name. And this is the default structure of the class that we get. So we need to add in some information for the country itself. And to save you watching me type it in, I'm going to copy it. It's not going to be an internal class, it's going to be a public class. So we've got a public integer for the country ID and a public string for the country name, and I'm going to set that to start with as an empty string. This is effectively to avoid problems with nulls. So that's the countries, and we'll save that and repeat the process for city. And for city, we've got an integer for the city ID, a string for the name, an integer for the population, which I'm setting to 0, again to avoid problems with nulls, and an integer for the country ID. That's obviously got to match the country ID definition that we had for the country. Now, in the next few sections, we're going to be talking about APIs quite a lot. So I thought a very brief and simplified explanation might be helpful. So what is an API? API stands for Application Programming Interface and is effectively the mechanism that allows two separate programs or devices to connect to each other and exchange data. An API is the messenger that sends a request from one system to another and then handles the response. In fact, request and response are the terms used by APIs. So in this example here, we've got a request being sent from device 2, which might be the client, to the server, and a response being returned from the server or device 1 back to the client. Now the request can be in a number of different formats, but for example, it could be give me a list of cities. So the request will go through to the server saying give me a list of cities, and the response will be a list of cities. Alternatively, or one of the alternatives, is that the request might be save this information about a city, and it'll pass. The request will be save this city, the ID is such and such, and the name is such and such, and the response will be done, I've saved it. So we can see that the request and the response are important parts of this. Controllers are going to be another name that's bandied about quite a bit, and it's the controllers are effectively the brains of a ASP.NET Core application. They process incoming requests, perform operations on data provided through models, and select views to render on the browser. Controllers are stored inside the controllers folder in the root of the app. They are basically C# classes whose public methods are called action methods. These action methods handle the HTTP requests and prepare the response to be sent to the clients, which is effectively shown here. So we've got device 1 and device 2. The device 2 sends the request to device 1. The controller handles the requests, prepares the response, and then sends the response back to the client. So we need to add some controllers in our application. In the server project, there is already a folder called controllers, and in there is already a controller for the weather forecast. This is where we're going to add controllers for countries and cities. So select controllers, right click and select add, and enter or select controller. And on the scaffold item, we've got a number of options on the left-hand side. We're going to select API, and we're going to select the empty API here and select add. We're going to give it a name, so I'm going to call it country controller. And click add. The empty controller is now created. We'll be adding a SQLite database later to store details of countries and cities, but we'll start by entering dummy data directly into the controller. To make life easier, we'll be referencing the shared folder throughout our application, so we can add the following to the top of Program CS in the server folder. So here in the server folder, we've got Program CS. We can open that and we can add global using Blazor countries shared at the top. If you've got a global, which is what we've got here, that's got to be at the top. So I'm going to cut that out and just put it in front of this one. One thing to beware of, and caught me out initially, is that we've got a program CS in the server project, but there's also a program CS in the client project. Make sure that you've selected the program CS in the server project. Now we're going to add dummy data for countries, so we can add the following to the country controller. So what I've done here is added a public static list of type country called countries, and it's a new list of country, and I'm adding two countries, one called United Kingdom and one called France. Fairly straightforward. Now we're going to repeat the whole process to add a city controller class, adding the dummy data for the cities. So to do that, we go to controllers, add controller API, and we're going to call it city. Select add, and I'm going to again just include some dummy data for cities, which I'm just going to copy and paste in here. So now we've got some data for some dummy cities with populations. So we've got city ID 1, London, and a population of 9 million, and the country is 1. Same for Birmingham. Similarly, country 1. If I scroll down, I've got some cities for France, and that's country ID 2. So the basic format of one of these API controllers, it's got a routing, and it's API / and then the controller, and then API controller. Now we need to now modify the controllers so that we can return data. So to get data for countries, I'm going to insert some or paste some code immediately below the code we've used to generate the dummy data for countries. But we've got to make sure it's within the public class controller base section. So for countries, we want it in here. And notice here that it's an HTTP GET, and I'm asking for an action result for a list of countries, which I've called Get Countries. I'm going to return OK with the list of countries. That's for us getting a list of countries. This method down here is for getting a single country. So HTTP GET and then the root, and this time it's just going to be to the country ID. I'll explain or show this in a little while. And the action result is going to be country get single country. That's my name for it, and we're going to be passing into it the country ID. So we're going to say, right, get me the country with ID 1, for example. It'll then go through and either find the country, in this case the United Kingdom, and return the OK with the country, or it'll return not found. Similarly, we want some code for the city controller. So down at the bottom here, make sure I'm in the right place. Exactly analogous HTTP GET for getting the cities, or get one city. We've got this, we're passing in the city ID. So we ought to test this as is. So save everything and run it. So we've got the local host here. This is the application running, but of course we've got no data to show here. We haven't added any forms or anything like that for the countries or cities. So we should be able to copy that address and append to it /API/country. And we get in JSON form the countries. So we've got country ID 1, country name United Kingdom, country ID 2, country name France. And similarly, if we put city at the end there, we'll get the list of cities, again in JSON form. If we were to put, let's select, say, country 4, which is city 4, which is Cambridge. If we put /4 on the end here, we just get Cambridge. That's pretty much as I wanted to cover in this video. If we go back to the code, we'll see that we've so far added models for countries and cities, and we've added controllers for city and country, and we can now run the application and return individual cities and individual countries, as well as list of cities and list of countries. In the next video, we'll be looking at how to present a list of countries as part of the application, but that's for the next time. I'll put a list of useful links at the end of this video, and I'll also include those in the description. Thank you very much for watching.